Good morning, everyone. A very warm welcome to the industry session about NG112 solutions. And I'm very pleased to chair this session. My name is Wolfgang Kampichler. I'm with Frequentis AG, and I'm the co-chair of the Technical and Operations Committee at EENA. And I'm very honored to introduce the speakers of this session. So we will start with Rick Jezierny from Atos and Iratxe Gomez. So they are going to talk about how to deploy end-to-end NG112 solution in the cloud. Quite interesting topic. And then we get some, I guess, fake news from Luca Bergonzi from Petite. He is talking about the NG112 CAD in the cloud. Oh, sorry, not in the cloud, but it's about the CAD. Oh, it's in the cloud, we will see. And last but not least, we have speaker Simon Ljungberg, and he is going to talk about real-time text bridge solutions. And yeah, that's it for the introduction, and I'll hand over to Rick to start with the first presentation. Thank you.
Okay, good morning. I'm Rick Jezierny. I'm the product manager for Atos. I'm responsible for the next generation core services portion of our solution. And
my name is Iratxe Gomez. I'm also from Atos, but I'm more on the PSAP side of things. I'm pre-sales manager for one of our public safety products, and I'm also vice chair of the EENA Technical and Operations Committee.
All right, I'll take the first half of the presentation to talk about the next generation core services solution from Atos. Okay, this is our complete solution that you see here, the Jezierny NGCS at the top, call handling and CAD at the bottom. Everything that you see here is an Atos product with the exception of a couple of things that I will mention. And everything is also now cloud capable. So our solution can be configured in the cloud. It can be configured typically virtualized in a data center, or if anybody really wants to do it, it can run on bare metal. Okay, next generation core services. A lot of you are probably familiar with this architecture. The box in the middle, these are our next generation core services applications that Atos provides. We do not provide the two boxes at the bottom in the kind of pinkish color. The lists and the ECRF, we would contract that third-party vendor to provide those for any particular project. Okay, we have the border control functions. We in our architecture use one on the ingress side, one on the egress side, a separate running application. Of course, we have the ESRP in the center, the emergency services routing proxy, really the heart of an NGCS network. We provide a media bridge for conferencing applications, and that includes text conferencing, also very important in the emergency calling world. We have a recording solution. We have an off-board policy store server, which typically is an application that our North American customers want, European customers not so much. And we also have a next generation logging service. This is something spec'd out in the NENA i3 standards. But our European customers are also asking us about the i3 type logging. So I'll quickly run over our different components in our solution. As I mentioned, the border control function, it's the first component in our Jezierny solution. It receives the call from outside the network. It provides your typical security functions, firewall, denial of service detection and protection, media pin holding. We do some SIP protocol validation. There's vulnerability protections, and there's some other proprietary security functions within our border control function. We do media anchoring, and redundancy is a topic that, especially in a cloud configuration, you have to spend a lot of time thinking about redundancy. You have to consider the fact that a lot of cloud providers don't provide the 5 nines or the level of reliability that you want to get out of your provider. So you've got to put some more thought into how you can provide the extra level of reliability that is necessary in an emergency calling network. So we've put some focus on it, especially in the BCF, because that's the first component that the call hits. We configure our BCFs in an active standby status, so that in each cloud provider you can have two BCFs, one active, one will take over at a moment's notice. And within the BCF, there's also a downstream redundancy function, which is if the BCF sends a call on, doesn't get a response, it can back the call off and try a different call path. So first point of redundancy in the network is the border control function. Okay. All right, next, of course, we have our ESRP, the Emergency Services Routing Proxy. This is based on a legacy VoIP carrier grade switch. It was well architected, and it was very easy to take this VoIP switch and turn it into an ESRP, just adding the particular functions that are necessary for emergency calling. This is, obviously it's the heart of the NGCS. It's where all the call routing decisions are made. It has knowledge of network statuses, what status the PSAP's in, what status the links are in, and so on, so that it can make real-time decisions about where to send a call. If a PSAP goes down, if a cluster goes down because of a link outage or something like that, the ESRP can very quickly make a decision to route calls to alternative destinations. And that's all based on the policy routing function. We won't go into too many details about policy routing, but there's a lot of conditions that can be specified. As I mentioned previously, we have an off-board policy store server that the PSAP administrators have access to through a web interface. It's a secured web interface. They can make changes to their policy routing rules, but the rules tend to be static. Once they're configured correctly, the ESRP will apply the set of rules in real time, and the rule set should account for situations where PSAPs go down and so forth. Okay, redundancy in the ESRP. As I mentioned, this is based on a carrier-grade soft switch. We run the ESRP in active-active pairs. The second node has all the transient data that the first node's working on and so forth. There's a data channel between the two that makes sure that the standby node knows everything that's going on in the active node. At the same time, the standby node is also processing its own calls. So if one node goes down, there's no loss of functionality, there's no loss of throughput. The second node takes the load off of the first node. And this can be geo-redundant, which is especially useful in a cloud scenario, where you can put your two pairs or your two pair halves in either different lanes or different regions in the cloud service, in the cloud service provider, to give you that little bit extra level of redundancy. And the ESRP also has some knowledge of its downstream node statuses, like the media server and the egress BCF, so it can make routing decisions internally and provide that extra level of redundancy, especially in a cloud scenario. Okay. We have a media service bridge function, as I mentioned before, very important for doing conferencing. It handles voice, video, and text conferencing. It also, in North America, we're still using TTY with Bordeaux tones. Kind of old technology, but our media server is Bordeaux aware. So it can pull out the Bordeaux tones and turn that into real-time text so that the PSAPs don't have to deal with this old technology. So as far as redundancy goes, the media service bridge function is controlled by the ESRP. There would be a redundant pair in place in the network. The ESRP knows which one is up, which one is not, if one is not up. So the ESRP can route any media service requests that it needs to help with the media server to an alternate if a problem arises. Our policy store server, which again I mentioned is off-board. This is based on the EENA standards. It's a separate node for maintaining the policy rules. We have a web interface for our administrators to do the rule creation and editing. We have access control down to the point that persons with the credentials for a particular PSAP can modify the rules for their PSAP, but not other PSAPs. And then you have county-level administrators, state-level administrators that would have a higher level of access. So the policy store server is redundant. We have a node in each cloud lane. The database is replicated. The secondary PSS can take over if the primary fails for any reason. And we have a witness node to avoid the split brain scenario where one database gets out of sync with another database. Okay, so what this, put this all together, and this is the full cloud deployment scenario with redundancy that we have architected for use, especially in North America, where we have duplicated aggregation centers coming off the originating service providers. The aggregation centers each have a duplicate BCF pair internally, so that the calls from the aggregation centers come into a cloud region, and they're load balanced between two lanes in a cloud region. And in each cloud region, you see the different applications configured, the BCF, the ESRP, the media server, and so forth. So that in the end, what we've got is redundancy from end to end. The worst case scenario is a lane goes down and the BCF at the aggregation center can back off and send the call down a different lane. Any kind of problem that happens within one lane can be dealt with either by its own BCF or again by the BCF in the aggregation center. And if you have a problem where a whole region goes down, then that's why you have the cross-connect situation with the aggregation center. So we think we've covered all the redundant scenarios or failover scenarios in a public cloud provider so that we get at least the 5 nines level of redundancy or reliability for a cloud application for the next generation core services. Okay, why do you want to use cloud instead of just going with your own data center and so forth? So first off, we can bring this up pretty quickly. We have pre-configured, predefined images. We can bring them up in the cloud provider of your choice pretty quickly. It's extensible. We have some interesting things that we can add on to it, such as smart cities applications, IoT applications. And it allows an administrator to focus on providing their own service. They don't have to worry about the data center. Lower upfront costs, you don't have to worry about hardware, you don't have to maintain the hardware, you don't have to worry about it becoming obsolete in 3 years, and so forth. So that gives us a lot of elasticity, a lot of redundancy, and ability to recover from disasters. Okay, in the interest of time, if Iratxe has some time left, I can take questions, or if you have other questions about the NGCS, please stop by the Atos booth. We're booth number 28 at the back of the room. So now, Iratxe, you're up.
Thank you, Rick. Thank you, Rick. And also, for the sake of mentioning it, at 10 o'clock, our colleague Jörg will be presenting the call handling as a service in the track one. So I will be, after Rick has spoken about the network side of things and the network side of things on the cloud, I will be focusing beyond the network. And what does it mean beyond the network? Network obviously serves to the PSAPs to operate as well. But when we talk about PSAPs in the cloud, there are some questions that we need to make ourselves. Sorry. Because, first of all, decisions about what type of cloud do we want or do we need to implement. Is it a private cloud? Is it a public cloud, a hybrid cloud? We need to orchestrate clouds. Sovereignty needs to be considered as well. And then some clients have shown us concerns about, do we want everything on the cloud or do we want parts on the cloud? Sorry. Do we want only parts on the cloud? So some clients have expressed that they're still a bit hesitant of having the productive environment on the cloud, but they're happy to start testing with non-productive environments in the cloud and then go step by step. And then, who's your provider? As Rick mentioned, we are flexible enough to adapt our solutions to the cloud provider of your choice. But yeah, that's a decision to be made. Is it one of the big cloud providers? Is it one of the not so widely known cloud providers? But that's a decision to be made as well. And then consideration about trustfulness, security, cybersecurity, and all those aspects that are key in order to avoid any outage, any critical breaks and so on. Those are questions that need to be asked very upfront. We have examples with the case of Google Cloud Platform, and by choosing Google Cloud Platform, for instance, they provide GCP, in short, provides the computer engine for the PSAP to run. And for that, the virtual machines and virtualization and all those aspects are provided in infrastructure as a service mode. The security aspects and the perimetral and intra-network security aspects are taken care of on the GCP side through their firewall solutions. And the, this configuration of the machines is done using configuration as code paradigm. And then, of course, the observability of the whole solution is provided also by GCP tooling in that sense. So one of the aspects we changed in our product offering for PSAPs in order to be adapted to the cloud offering from the PSAP point of view is that we implemented, together with our UCC colleagues within Atos, a WebRTC-based call handling solution. And that allows us the flexibility to deploy the solution in the cloud and also to provide remote access to our PSAP solutions, because we are non-dependent on on-premises installations anymore. We don't need physical phones on premises anymore. We have zero on-premises deployment if we don't want to deploy anything on premises. And then, in that sense, this adaptability has provided us this flexibility to offer the solution both in the cloud and on premises based on the same paradigm with the WebRTC that gives us access to voice, text, and video as well. Another change that we've done in what we do in terms of our product offering and solution offering for PSAPs is we implemented observability components that can be accessed by the clients themselves from the product environment, and observability and log aggregation and all those aspects that gives us an overview of what is happening at any given time and compare with past situations and so on. It's important for us as well. In the PSAP, also not just the call handling and CAD solution, but we are also considering in the PSAP and beyond the PSAP components that will go beyond the PSAP, like the critical communications aspects, including radio dispatching and multi-network dispatching. And in that sense, we have adapted our products so they are cloud-ready, cloud-compliant, and as part of the end-to-end cloud solution. And also with the recording systems, the logging systems, voice and text and video recording systems that are all in the cloud and can be offered both on premises and in the cloud. And yeah, 2.5 minutes to almost 3 minutes for questions. If you have any questions for Rick or questions for myself, please feel free to do so now. Luca?
I have a question for you.
Okay, Rick, come ahead.
Thank you. I saw the interesting part about this policy routing function in the SRP, and I was wondering, so you need to be in touch with the, let's say, network or PSAPs to understand if the selected destination is available or not available, and so on and so on. So in the case where all the network of PSAPs is Atos technology based, the situation is quite simple to manage. Have you ever found a situation where you needed to, be in touch with a heterogeneous network of technologies and how did you handle it?
Yes, you're actually describing the state of California.
Ah, okay,
right there.
good.
Okay, so one of our nodes that I did not present is called an LPG, a legacy PSAP gateway. In California, there's 450 PSAPs. About a third of them are IP capable, but the other 2/3 are not. So at each one of those, we have installed a legacy PSAP gateway. The gateway, we use a third-party product to do the actual protocol conversion from the SIP to the analog trunks. But the legacy PSAP gateway also has a component that monitors the status of that PSAP and informs the ESRP via the standard SIP subscribe notify mechanism. At the same time, the ESRP is pinging at the application level all of these legacy PSAP gateways as well as the IP-capable PSAPs. So if the link goes down, we know by not receiving the response to the ping. So yes, we can deal with a heterogeneous PSAP network.
Thank you.
Mm-hmm. Okay, any other questions, quickly? Okay.
Okay, then many thanks, and let's continue, or let's... Okay, let's welcome our next speaker, Luca. Luca, the floor is yours.
Okay. So today we are talking about next generation 112, but touching a side aspect of it. As you've seen in the previous presentation and in many other presentations at the EENA conferences, NG112 is very much about call handling and call routing and so on. What about the CAD? So the CAD is the computer-aided dispatch, usually found into CAD to PISA premises. And we heard a lot of people saying, oh, I have a next generation CAD and so on and so on. But I mean, does it really mean something, having a next generation CAD, considering what we heard so far? We've been talking about, briefly this kind of architecture. Also, Rick was talking about that. So we have the ESINet with ESRP, ECRF, BCF, and so on, the LIS over there, connected with several other elements. So in this picture, where's the CAD? The CAD usually stays here and here. It looks like to be outside somehow the ESINet and outside maybe the scope of NG112. So can we really talk about NG112 CAD? Well, the answer, in my opinion, is yes and no, because the CAD, of course, will have impacts on its architecture when an NG112 network comes in. They are not usually managing media contents directly, so they are not managing the calls or video calls or other things. They are not used to routing calls, so the CAD is not used for that. The CAD is probably being invested by the results of what's happening. However, a CAD usually is managing geolocation information. A difference, quite a big difference between Europe and the US, where the CADs are typically handling the location information from the call. And also CADs can be managing some media, such as SMS text and so on, depending on the desired solution by the customer. So in principle, like I said, yes and no, they are impacted by an NG112 migration. For example, in this way, they would need an integration with LIS to retrieve the location information from new type of sources of location. We are currently dealing with network-based location, sometimes apps, AML, and so on, but new sources of location are coming. And they are also potentially using new forms of messaging, not just SMS or text, but WhatsApp or similar applications that can be interconnected with the CAD and to get in touch with the population and so on. So RTT, SIP-based text, SMS, plus new services. No? In a way, they are impacted. we are concentrating on this because historical Beta 80 is a CAD developer. We have been working on NG112, so eventually the core elements of NG112, ESRP, ECRF, LIS, they are all part of our portfolio. And it's important to notice that our CAD already speaks with LIS, whether or not you have an NG112 network installed. So by this, let's say, interpretation of NG112 CAD, we can say that actually, yes, Live First CAD is NG112 compliant. But is that all? So is that all you need to have an NG112 CAD? This is just, like I said, impacts on the CAD coming from an NG112 deployment. We think there is more. We think there is more, and we wanted to give an interpretation of NG112 CAD in a very CAD-oriented logic. So first of all, a platform which becomes a building block for what's coming up in the future. There are technologies now that have been studied, but others that we simply don't know if and when they will be applied to emergency services. So the idea we put into our CAD was expansion without replacement. We don't want customers to change their technology every few years just because it's outdated and so on. So we try to build, first of all, in architecture, building blocks to really be able to call our CAD an NG112 CAD. For example, service-oriented architecture, we think it's a basis of deployment of a CAD today. What is it, in principle? Very briefly. A monolithic CAD may require, when integrating new features like CCTV integration, to be somehow replaced partially or totally, no? To be able to include new functionalities. In our service-oriented architecture, the CAD is already made of blocks. So in principle, you already have a block structure of services, each of them working on a specific topic of the CAD. And when you have to add a new service, it's basically one more. So you don't have to replace the existing ones. You have just to create the connections between them. They already speak with each other as if it was a network of elements inside a PSAP installation or multiple PSAP installations. We went from single tenant to real multi-tenancy, which means, again, instead of going for an installation on a single PSAP or on a single customer, you may actually gather multiple customers on the same project and give them at the same time the same application with the same functionalities, but keeping the environment completely separated, segmented, so that if you have a situation with a single tenant, each of them would be separated, maybe talking to each other, duplication of data necessarily if they're, let's say, insisting on the same environment, and exchange of data between databases, no? Which means, for example, creating algorithms and functionalities that didn't exist before when you had in mind just one single pillar of those three. With a multi-tenant, this completely disappears. You have data policies. So there is a single, let me say, data container, or database if you want, or something like that, where you define your policies just by configuration. And there is data unification. Therefore, you can add as many tenancies as you want in the same installation, and they will keep their own policies, share them, segment them, depending on what the necessity are. So you open up the barriers, basically, or you close them when it's needed. And the third pillar about this was the open APIs. We know that a PSAP environment is it's not a CAD, it's not a PABX, it's all of them plus many other satellite functionalities which may be provided by third party and so on. But in the end, they create an ecosystem. And the most important thing today, since this ecosystem is going to grow, in any case, by new functionalities and by new technologies, it's important to have an open environment. So our CAD effectively has more than 60 different REST APIs. We have already found situations where you can simply push data, retrieve data, modify data. You can do whatever you want, basically, with these APIs as an external developer. And you will see in this session also a presentation about a training software / evaluation auditing software that was built and developed using our APIs. Our investment on that, our activity on that was zero development, literally zero development. Just a few conference calls to define the details. But in general, the thing is that you may build completely separate softwares and environments using our APIs and defining the interactions and so on and so on. You can even rebuild the user graphical interface through the APIs if you don't like it, but you will. Finally, the rich incident metadata is what we believe will be part of the future when talking about NG112. So let's make an example. No? A medical case when somebody's calling 112, feeling chest pain, stuck in a restroom. Here we have the example of Dubai Mall because it's a very big structure with 4 floors and so on. And so what do you do if you are a foreign tourist stuck in a restaurant in this place and you need to call 999? Well, the idea is that basically the CAD may come up with the map of the Dubai Mall. It may define where the defibrillators are if you are being diagnosed a potential cardiac arrest, showing also where the cameras are and access automatically to the cameras. Plus, give you the direct security and contact details of the mall managers to say, hey, look, we have been called with such situations, send out the first responders team to the location we give you, inside the mall, first floor, whatever, and so on. And I'm not making this example because it's just an example. You can come to our booth and see how it works from the CAD perspective, from the call taker and dispatcher perspective. Another typical example is now coming with its license plate detection and so on. So what do you do in this case? You can video and record the timestamp, connected automatically with the CAD incident, automatically without any user to be involved, and basically define already the information on the vehicle data and so on coming from a road authority, transportation authority, and so on, and fill in all the data. So this is all going through the APIs. And eventually then dispatch a patrol and share with the local, with the on-field team the details you collected in the CAD. So this is another example where everything could be automatized with very little intervention from man or even to zero. And of course, we are also talking about real IoT integration, which includes situations where you have a classical, situation with fire. So we cover all three now, medical, police, and fire. You dispatch your fire brigade teams, your engines or ladders, and so on. Plus, maybe you want to have a drone connected to your system, which makes a survey of the situation, can send over a streaming, live streaming video, and it can be connected with the CAD. The CAD can even actually invite to that streaming other people from the PSAP agency, managers who are not there, or other things like this. And again, you can see an example at our booth of this particular scenario. Concluding with wearable sensors and monitoring of the firemen that are on scene, which is always important. Now they are experimenting and commercializing a lot of these elements that are included in a body suite for fire brigades. So the monitoring of fire brigades is another IoT feature that can be implemented with APIs in our CAD. And an example on social media. Social media, we know they are not really currently used on PSAPs for managing emergencies, and we know the reasons. Your, let's say, identity is not guaranteed. There may be spoofing situations, and I mean, they are not really the most reliable source of sending an emergency request. So we gave an interpretation on it. How can a PSAP use social media in another way? Is there another way to use it efficiently? Well, for example, what we implemented was the idea of having a caller, so a regular caller, description of emergency, and so on. You fill in the form of this emergency, and then there might be information which are unknown. Something is beyond the words of the person that is talking on the phone. And what if you would be able to analyze social media activity in that area, looking for a particular environment, vocabulary, location, and so on. Suppose you're calling for a smoke, and you are making this call saying, I see a smoke from my window, and potentially that's a fire. But you cannot see where the smoke is originating from. Maybe a car, maybe another apartment, or something like that. But what if people around this same incident, for example, would be using Twitter to say, I see a smoke, or taking pictures of it and stuff, and the PSAP would be able to analyze what the other people are doing in the same time as you are receiving the call from the same location, and be able to gather all this to effectively understand that, okay, it was a fire from a car, or it was a fire from an apartment that the initial citizen calling was not able to see. This is another feature which is currently available. So these are all things that are, in my opinion, worth to be mentioned as next generation CAD functionalities. They are not related to the core part and the standard part. Yes, I know that, but again, otherwise, a CAD has really little to do with this. So if you want to really talk about NG112 CAD, you should look at that. And also give a look at the future. We have situations with augmented reality, right? And the transition of this, so using geolocation information to give a policeman the location of its colleagues, the location of the caller that was calling for the emergency, and so on, is not that complicated, given that the instruments are there and the CAD has open APIs for doing that. So, like I said, NG112 CAD is not a standard as in a component. There is no even standards to define a CAD. They are more or less defined in terms of operations and in terms of actions, but not in terms of technology. How do you face then the upcoming new technologies and so on? So we wanted to just give you the idea of having the correct building blocks that you should have now to face the future challenges that are coming. So we think we had the building blocks, correct building blocks to face these challenges that will be sooner or later faced by PSAPs. And that's it.
Thank you. Thanks, Luca, for keeping the time and for this nice presentation. Do we have any questions from the audience? So we have time. Iratxe, please.
Okay, thank you. Luca, so do you see any standardization on the PSAP to the field aspect of operations and technical aspects in the near future?
Yes, thank you, Iratxe. This is a very interesting question, and I think we've been talking internally now with the EENA community about that as well. I think that if a standardization has to come, it has first to be analyzed from the process perspective. So all the examples I made, especially the last one, so far away, in my opinion, in the future of augmented reality, it's like sometimes technology for itself. No, we really need to analyze if this is needed in the way I described, or if this is just my own imagination and so on, right? I think that working groups on that should start to be created, you know, in order to really understand where this is going and to understand if, you know, maybe what they have right now is enough, but I don't think so. I think that with the, you know, maybe 15 years ago, nobody would think about having streaming services for video and so on. No? Videotapes and Blu-ray were enough. But today, we all know that at least everybody of us has one subscription or something. So I don't want to say we need to create a need, but we need to analyze if this is the perception is already there, and translate this perception into technological responses to it. No? Sometimes the need is there, it's not being described yet, or it's not surfaced yet. And, you know, working groups on that are required for at least trying to define a standardization.
Do we have another question? Michael.
Hi, Luca. I really like the idea of the open APIs. Can you tell us a little bit about the process when developers using these APIs, and how do you make sure that external parties do not break the core functionality of your CAD?
Oh yeah, there are already some examples existing on that, but the idea was that if you remember the description of the service-oriented architecture, when we built this type of model, we decided every service would be speaking with others through an open interface. So in principle, you can think that every of these services is already using the same APIs with each other that we expose to external services. The example we made of this training platform covers exactly what I said. So in principle, you have an authorization of accessing the APIs which are, not open to all. No, it's like a process of authorizing the client, let's say on the other side, which wants to be interconnected with the CAD, and through that you are able to define a certain number of operations. From very big ones like create a new incident with these parameters, to even attach a file to an existing incident. The example is the automatic defibrillators, the AD devices, or even the ACG. That's even better. The ACG devices which create traces. Today there are on the market things like create a trace, produce a PDF of it, and through the APIs you may directly send it to the CAD and attach it to the correct event where the ACG was used. And it's just a small functionality, attach a file. No? But then you can do it, and with zero effort on our side. The discussion, the dialogue between the CAD and the LIS, for example, is made through APIs. The CAD uses the standard NG112 logics to retrieve location information, not for routing in this case, but afterwards when the call has been already routed to define the location and so on. But everything else, everything that you can do inside the CAD, it's made through an API, between services. So imagine as a third party becomes another service attached to the architecture. And there are, like I said, so many APIs that I don't even know all of them. You need to ask to the technicians. But that's the story. So there is no difference. Being inside, being a service or being an external provider, it doesn't make any difference for the CAD.
Okay, thank you. Thank you, Luca. Let's welcome our next and last speaker. Simon is now going to talk about the real-time text bridge solution, and Simon, the floor is yours.
Right. Excuse me. My name is Simon Ljungberg. I'm the product manager for a company called nWise, and I'm here to talk to you about RTT and our product, the RTT Bridge. First off, I'm going to start with a bit of a recap regarding real-time text, because real-time text it's an easy concept, but it's so easy that it gets a bit complicated. Then I'm going to just give you a bit of background on nWise and why we are here. And then we're going to get into our product, the RTT Bridge, and how it can be integrated into a planned or even an existing architecture. So, real-time text. It's text that's been transmitted as you type, as opposed to message-based communication where you push send or whatever you do, press return. And it's that simple, really. And unfortunately, what makes it complicated is that it's so simple that many solutions, the problem is solved in a different way by everyone that gets their problem, and that makes it complicated. And why is it used? Well, it's the preferred way of communication for people that use text as their primary medium, as opposed to message-based communication. And it's very superior to message-based in a way that, for instance, a Braille user that read with their fingers are able to read incoming text as it comes in, as opposed to waiting for a long message to come in, then read it, then start typing. And in a situation where every second matters, it's a lot quicker to be able to follow along, just as you would in a spoken dialogue. So to get back to the problem, the power of standards. Just sending real-time text as you type, you can send it in a number of ways, in a WebSocket, in WebRTC, as we saw Atos speak about. You can transmit it using a number of different standards. But the problems arise when you can do it in a number of different ways. People do it in a number of different ways. And the people that really need this technology, they usually have one way of communicating, one device that's their phone. And in a situation where every second matters, you don't want the person in the emergency situation to be looking for the specific app that's been developed by the emergency services to contact them, that they're not used to the interface, or they're not used to how it works. You want to be able to do just like any hearing person would. You make an emergency call just by calling. So it's very important to use the standards. And the main standard in the accessibility world for real-time text is RFC 4103. It's used in, I can't remember how many countries now, but at least 9 or 10 countries in the Europe. It's the standard that's mentioned in an EENA I3 standard. It's the one that's being tested in the EENA plug tests as well. RFC 1971, the standard for multi-party real-time text, also the one that's been specified in the I3 document. And RFC 8865, which is the standard for sending the same payload using WebRTC. So why nWise? Well, we are specialists in accessible telecommunications. We've been doing this kind of stuff since the start, which is about 20 years ago now. We're global. We have global operations. We're in 12 different countries, primarily telecom and government customers. And we've been enabling calls from people who are deaf, deafblind, and hard of hearing to emergency services for about 20 years. First off, initially with relay services that use audio, video, and RTT, and then make regular phone calls to the emergency services. But now even with emergency RTT directly to the emergency services. And we've been working with RTT according to the RFC standards since 2005. So the nWise RTT Bridge, what it does, is almost as important as it is talking about what it does, is saying what it doesn't do. What it does is that it bridges text. It creates a bridge from text sent over different, using different techniques, different RFCs, to one that's supported by the other participants in the call. And what it doesn't do anything else. It's API driven. It's designed to just handle text, not mess around with any other media, not being in the CAD or handling anything other than just core text and APIs to be integrated. It's designed to be integrated, as I said, and it supports multi-party calling. And multi-party calling, it's quite different when it's done with text as opposed to audio or video, and especially with real-time text. With messaging, it's not that complicated. You set up a text group and you see who sent each message, but when you send each character, if the person receiving them isn't able to differentiate between the sender of each character, you're just going to end up with a lot of gibberish. So it's quite different. It's designed to handle recording, which is also a bit different with real-time text than with other medias because of that same dilemma. We'll get back to that. It's designed for deployment in an emergency environment. So it's designed with a multi-node active-active kind of setup. To refer back to the design that Rick was showing for Atos, we would have sort of the same design with nodes in each of the lanes of Atos design, as well as in the different regions. And redundancy with real-time text is a bit different as well, because of different capabilities, and you're not being able to just send out the text as it comes in, as you would with audio or video. There's actually buffers in the conference bridge that need to be redundant, so you don't lose any characters, because losing media when it's text, where every package has a bit more weight than it would be with audio or video, is a lot more important. It handles bridging between protocols, and it's highly configurable, because we don't know how the use case would be in a different deployment. And the things that can be configured is how you switch between sources when you have multiple people writing at the same time, what's considered a message, and so on and so forth. So multi-party calls with RTT, it makes life a lot more complicated to handle multi-party calls than just single-party calls. So the question needs to be answered is it necessary? Well, it is. For instance, for call transfer, you want to make sure that when you transfer a call to a second party, the first person can stay in the call and make sure that the transfer did go through. Or you could be inviting a specialist nurse, for instance, as in our demo in our booth, without releasing the call, having the telecommunicator staying in the call. A very important note is that it avoids repetition. One of the things that we noticed looking at transcripts when we were setting up our demo is that in a voice call, there's a lot of repetition when a second person enters the call. The first questions that had already been asked by the telecommunicator are asked again, which is, it doesn't do that much damage sort of when it's spoken, because it's quick. But when you're communicating with someone that's typing and even reading with their fingers, and turnaround is very slow, repeating a question that already been answered it's using seconds that could be vital, or minutes even. So avoiding repetition and having first-hand information available for everyone on the call could be life-saving. Well, the differences between multi-party calls with text from multi-party calls with audio is quite simple. You can mix it together into a single stream. If people are talking at the same time, you have to repeat yourself. It's not that bad. Or you can have selective forwarding. That's that the active speaker is the one that's getting through. I think everyone now that's been working on Teams the last years probably been annoyed by that function. Someone starts talking and the audio keeps cutting out. But the important thing is that it's no immediate need for all the participants on the call on a signaling level to be aware that there's multiple people on the call. You just hear multiple voices. So there's no need to add functionality to your phone just to have multiple people in the call. Same goes for video. it can just be mixed together into a composite of the combining sources. So you have, well, it's basically a Teams meeting. Just Teams, I presume, uses forwarding to get all streams, but there's no immediate need to be multi-party aware in this case either. An MCU can just mix everything together and prepare it for you. But with text, that's not the case. Because if you get, as I said, if you get characters from multiple people mixed together, the text is not going to make any sense. So you really need to be multi-party aware so that you can differentiate between text coming from person A or source A and source B. Or you need to have the stream manipulated so that text from person A is arriving first, then switching over to text from person B. And you also need to insert labels to say this is text from person A and text from person B, and so on, to make it understandable. And if you have a call with multiple people typing and participants that are not able to differentiate between text coming from different people, you will get potential queuing. So the conference bridge handling text could have text that's been sent by a person, by a participant in a call and not been received by another participant. So person A thinks that my text has been sent, that's what he sees, but participant B hasn't yet received it. So that's what makes redundancy a bit more complex when managing text, because the payload itself needs to be redundant. So we've designed our RTT Bridge to have a multi-layer redundancy with active nodes in the local cluster. What will be in Atos had a better picture than me, so I'm referring to Rick's image. What will be in Rick's lanes, as well as geographically redundant clusters, and they're active. So every dialogue, every conversation or conference, technically, has a primary node that the call is handling, but the states is replicated in the local cluster, and so they're all up to speed and can take over on failover, as well as in the geographically redundant clusters. So it's not just calls and sessions that need to be redundant and not lost, but call content as well. And it's also this redundancy design that makes it able to replay an ongoing multi-party call for a participant that's joining later. So a call could come into the PSAP, and the teleoperator answers the call, asks some initial questions, then realizes a specialist of some sort need to be connected to the call. When that person is connected, can have the entire conversation replayed, or not replayed in real time, that's inefficient, but join the conversation and have all the messages resent to them, which is not a part of real-time text, as it's real-time just as voice or video as a standard. We support recording with dedicated components, because recording real-time text can also be handled differently. Having it in a dedicated component also makes it easier to have it either distributed or locally or centrally, depending on where you want your recordings. If the recording should be at the PSAP or in a central location. But since the participants of the call can join the call with different configurations or different abilities, they can have different perceptions of the call. So the recording can be configured to either have sort of the objective view of what's going on in the call, or even be replayed from one of the participants' perspectives. I need to speed up a bit. The bridging between protocols. The basic bridging between protocols is just bridging between multi-party aware and multi-party unaware. That's the the participants that can differentiate between sources and the ones that need the manipulated stream. We also have multi-party aware to multi-party aware using RTP to WebRTC. We have added, just to make it more integratable, a JSON over WebSocket interface. Because if you have a web client, for instance, WebRTC does not support text over RTP. Probably never will. There's a separate RFC for it, but it could be just easier to just set up a WebSocket. And that doesn't require negotiation either, because it just uses the existing negotiation to pick up the text stream. So how about non-real-time text formats, like MSRP or ZIP messages? Well, those can be integrated as well. So what we have is functionality to decide, guess sort of, what is a message. So an MSRP client can join the conference bridge or the RTT bridge and send their text as messages. It's sent forward as RTT. RTT is received from the other side and then divided into messages based on characters, new lines, or timing. It's designed to be integrated, so user access, LDAP, all those things have been thought of, but I won't have time to talk about it now. Can be integrated in a serial, parallel way, or using dedicated border controllers. There's, as I said, API driven, so we have multiple APIs, just as life first component. The most simple mode of integrating is just a serial integration, where the RTT is able to fork the request to an existing media handling component, so that the central brain of the system don't need to be able to handle parallel conference bridges. If it can be deployed in parallel, where signals are sent to both. And it can also be deployed in parallel using a dedicated border controller that splits all the signals. Basically repeating myself. Text can be sent as RTP using different standards, also over WebSocket, and that does not require dedicated negotiation. So what this gives us is the ability to provide a unified text interface where all the different text RTT formats or non-RTT formats can join a text bridge, and that get presented in the same way to the PSAP or to the CAD. And well, that's about it. I think I've used up all my time. So I think that's the last slide as well.
Yeah, thank you, Simon.
I can just add, since I used up all my time, we don't have time for questions, but you feel free to come by our booth for any questions or look at what this actually looks like on a running demo.
Oh, okay, thanks. And thanks for joining the session. Just a quick announcement. So here we will continue with public warning solutions, part 1. And there are for sure other tracks, if I can find them. So there is one interesting parallel track in track 1. It's ensuring continuity of emergency communications. And then we have in track 2, strengthening the engagement of civil society and transforming. Yeah. So again, thanks for joining the session and have a great day. Bye-bye.